A point charge of 5 cos 10 raised to minus 7 pi t microcoulomb is located at point P1, that is 0, 0, 15, and minus 5 cos 10 raised to 7 pi t microcoulomb is located at point P2, that is 0, 0, minus 15. These both points are in free space. Then we have to find the potential at P r equal to 3000 theta 0 and phi is also 0 at t equal to 150 nanosecond. So first step, the coordinates of P are given. So we write down the given, that is coordinates of point P are r equal to 3000, theta 0 and phi is also 0 degree. So this is in spherical coordinate. We write down here as r theta phi is given. This is spherical coordinate system. So first we consider this coordinate into Cartesian coordinate. First we convert these coordinates into Cartesian coordinate, as we know that x is equal to r sine theta cos phi. These are the basic formulas for the conversion. So it is 3000 sine theta is 0 degree, cos is also 0 degree. So x is equal to what? 0. Now y is equal to r sine theta sine phi. So it is 3000 sine 0 sine theta sine 0 sine 0. So y is equal to also 0. And third one, z is equal to r cos theta. So it is 3000 cos 0, which is 3000. So coordinates of point P in Cartesian coordinate are, it is 0, 0, 3000. So the spherical coordinates are converted into Cartesian coordinate. Now step 2. Step 2. Potential due to two charges. Q1 and Q2 is V is equal to Q1 by 4 pi epsilon 0 R1 plus Q2 by 4 pi epsilon 0 R2. It's equation number 1. Now what is R1? R1 is distance between P1 and P1, and R2 is distance between P and P2. Therefore R1 is equal to square root of 3000, so it is 2985, and R2 is 3000 plus 15 square, it is 3015. So we substitute this R1 R2 value in equation number 1. So Q1 is given 5 cos of 10 raised to minus 7 pi t, as it is microcoulomb 10 raised to minus 6 divided by 4 pi epsilon 0 into 2985 plus it is minus 5 cos of 10 raised to 7 pi t into minus 6, as it is microcoulomb, and 4 pi epsilon 0 R2. R2 is 3015. So what is T? T is given 150 nanosecond, that is 150 into nano means 10 raised to minus 9 second. So we substitute these values here. Time, we have the value of epsilon 0, so we calculate it, and V is equal to 15.0548 plus this part is 0, so it is 15.0548 volt. So in this way the potential at point P is calculated. So first the coordinates of P are given in the spherical form. We have to convert it into the Cartesian coordinates, Cartesian form. So first step is conversion, and second step is the substituting the values. Next problem. Third problem. An electric field in rectangular coordinates is E bar is equal to 6x bar ax bar plus 6y ay bar plus 4az bar volt per meter. Then find first Vmn point M and N are specified by point M is 2 6 minus 1 and N is minus 3 2. And second, find Vm if V0 at point Q 4 minus 2 minus 3.5. So first we will calculate E bar dot dl bar, and this is rectangular coordinate system. So dl bar is equal to dx ax bar plus dy ay bar plus dz az bar, and given is E bar is equal to 6x square ax bar 6y bar plus 4az bar volt per meter. Now the dot product of similar unit vector is 1 and dissimilar vector is what? 0. We know that the dot product of similar vector is 1 and dissimilar vector it is 0. Therefore E bar dot dl bar is equal to 6x square dx x bar 1 6y dy this is 1 and 4 dz. Now first is calculation of Vmn. Now here Vmn means what? Vmn means what? It is the potential difference between the points M and N. So Vmn is what? It is the potential difference between point M and N. So point N is taken as a reference point. So Vmn is equal to n to m e bar dot dl bar. So it is n to m, equation is 6x bar dx, 6 bar dy plus 4 dz. Now point N is what? Point N is, it is 2 6, sorry, point N is -3 2, and point M is 2 6 -1. So the variation of x is -3 to 2. We write here variation of x is -3 to 2, variation of y is -3 to 6, and variation of z is 2 to -1. So therefore Vmn is equal to minus of integration -3 to 2 6x square dx plus -3 to 6 6y dy plus -1 to 2 4 dz. So it is -6 into x cube by 3 -3 to 2 minus plus minus minus 6y square by 2 -3 to 6 minus plus minus minus 4 z -1 to 2. So we substitute these values here at the place of x, y and z, and we get it is -70 -81 plus 12, that is -139 volt. So this is the answer of Vmn. Next part of the problem is, second part is calculation of Vm. Now here given that V equal to 0 at Q 4 minus 2 minus 3.5, that is point Q is reference point, point Q is reference point. So Vm is the voltage, Vm is the voltage, that is Vmq. So we write down Vm means Vmq, which is equal to integration minus q to m e bar dot dl bar. So minus q to m 6x square dx plus 6y plus 4 dz. Now here point Q is what? Point Q is 4 minus 2 minus 3.5, and point M is 2 6 minus 1. So x varies from 4 to 2, y varies from -2 to 6, and z varies from -3.5 to -1. Therefore Vm is equal to integration 4 to 2 6x square dx minus integration -2 to 6 6y dy minus -3.5 to -1 4 dz. So it becomes -6 into x cube by 3 4 to 2 minus 6 into y square by 2 -2 to 6 minus 4 to z plus 3.5 to -1. So the final answer is 6 volt. Value of Vm is 6 volt. So in this way the value of or the voltage of Vmn and Vm is calculated. This problem was asked in exam for 8 marks.